Well, thank you all for coming to the talk. We we many of us live our life in the legacy code arena. 40 years of COBOL, Fortran, Basic, maybe some C, maybe some C++. No one, no one really knows who's calling what to whom, doing what to whom, and when there's an issue, trying to trace through the code has always been a problem. We solved the problem. Well, someone created this excellent product called Doxygen, and I think it created right here actually in Sweden. And it's a really good product for documenting C, C++, and some Java code. The trouble is it doesn't do COBOL, it doesn't do BASIC, it doesn't do Fortran, it doesn't really like any BMS extensions, it hates logicals, doesn't like any CDD whatsoever. And unfortunately, most applications that we come across, certainly in the BMS space, are COBOL, Fortran, Pascal. So what we decided to do was create a bunch of front-end parsers for Doxygen. And now we will show you Doxygen a bit later on if you've never used it. It's a tremendous tool. We have C and C++ code. It is beautiful. Documents code catalogs it, indexes it, and produces these beautiful call graphs. The trouble is, a lot of the code, of course, is not C and C++. So we created this front-end parser for each of the languages. And so we support Fortran 77. And now Doxygen does do a little bit of Fortran support, but it's mainly Fortran 90, where it's variable length, variable records and not fixed formats, as in Fortran 70. So it only does about 20% of the code if you give it Fortran 77 data files. It completely freaks out about COBOL, absolutely hates COBOL in every single way you can imagine. Pascal, same way, has no knowledge of Pascal and no knowledge of BASIC. So legacy map is a way of taking all of these languages and funneling it through so Doxygen will understand it. The idea is to create these call graphs. So any one module, who does it call? And looking at those modules, who calls into it? Now, we also expanded it. I may be getting a little ahead of myself here. Actually, I am getting a little ahead of myself. So Doxygen, let's go back a little bit. It's open source generator, and it produces these HTML graphs and indexes. It's a really excellent tool, and it runs on everything. As I said, it also uses, have you heard of Dot and GraphViz, two very old tools that create these beautiful maps, which we're going to see in a minute. So for instance, as an example for COBOL, now the same can be applied to Fortran, BASIC, etc. The caller diagrams, or we process the COBOL to create this meta language that we can feed into Doxygen. In addition, we can go through the RDB, the SQL mods, and the SQL and create these links about the database. So on each database set of SQL queries, you can say who updates the database, who deletes the database. It's pretty much who reads the database. So you also get the code calling other bits of the code. You also get to see when it calls the database, who's updating the database and who is calling that code that does the updating. All pretty useful stuff if you're trying to decode a complex 40-year-old application with 6 or 7 million lines of code. It says here we do the O1 level. In addition to doing the call graphs, we also can bring in the data structures. So we can look at the records and say, what type of data is it? Is it fixed length? Is it packed decimal? And of course, it handles copybooks. And you can see this for each of the other languages as well. So records, structures, includes. We also handle the, as I said, the embedded SQL and SQL mods, which is particularly handy. already talked a little bit about the various database accesses that we can process. You get a really nice idea about this 4 or 5 million lines of code, how it all hangs together. And we're actually going to see that a bit later on. So in terms of COBOL, we scan the code, we look at the exec SQL blocks, or we look at the SQL mods, and we color code. We also post-process the Doxygen and color code the routines and create different shapes. So we're going to see some oxy shapes. I think, and now we're about to see, so complete call graphs, this is duplication really, complete call graphs of all the database accesses and all the code. And here's some of the color coding we use, and the octogen, triple octogen, tab, whatever. And this is pretty typical. So you'll see the database accessing in yellow, and the sort of deletes in blue, and the various.
Actually, the colors are by database. Okay, so everything that's yellow, that's one database. All right. And then each of the database, that's why you see main DB everywhere. And then underneath it, after that, you have the table that is being accessed, okay, within that database. So you can see right away which databases are being hit, and then you can go into that. And then as John is saying, the shapes tell you what you're doing to that table. So the triple octagon, or not the triple, the octagon over there that he was tripping over, this one's an update, okay? So this program at somewhere in here in transaction properties is calling this, and it's doing an update to that table in that database, okay? At the bottom here, that's a file. It looks like a file. That's a select statement. You're just reading, okay? We also do fetches. We do deletes, the inserts. They've each got a separate shape, so it's easy to figure out what's going on inside of your database. And when you've got multiple databases, the color coding is helping a lot to do that, to identify. Okay, sorry.
No, this is your baby.
Yeah.
So yeah, I'm just, and this is what you see here is a typical Doxygen screen. Now, in this particular case, this is actually our Pascal to C++ translator, which it's designed to do. So if you've got anything written in C and C++, Doxygen natively will just give you this. Of course, the trouble is that this is in COBOL, and how many people have C and C++, but everything here is clickable. So if you want to see who calls this method, it'll take you back and show you the callee and caller for it. And you have a complete index on the left-hand side. Kind of boring. Now, what's more interesting is I'm just really, of course, teeing you up, my lovely assistant Denise over there.
Mr. Comedian here. Very good. Thank you, John.
Oh, no, I'm just a warm-up act.
It says I'm early. Will the organizer let me in?
Yeah, right here.
Oh, it's recording me.
I think we should be fine now.
Okay.
Yeah, so you just share and it'll replace.
Okay.
Maybe I pop out.
So this is, as John was saying, we do pre-processing of, I'm going to talk COBOL, okay? But we do the same thing for Fortran and Pascal and some of the other ones. The example that we're going to see here is all COBOL. It's an application that exists, and you're not going to be able to read anything because I obfuscate all the names. So I have to. But you will see what's going on in here. So the first thing that we do is that we scan the databases, whether we connect to RDB or Oracle or read the RMU or whatever. We load up the schemas of the database and we slap them in special files in Doxygen. So that's one aspect that we do, okay? So at that point, for each table, for each database, there's a set of tables, and for each table, there's a set of procedures that you can do to it. Fetch, select, delete, insert, and update. Okay?
Can you,
So if you want, I'm sorry,
You'll mute
can you
you.
disable the,
Yeah, she'll mute your.
Sound? in your PC?
turn off your speaker.
It's playing yourself back.
Like
You
that?
Back to yourself, yes.
Oh, that's why I was listening to myself. Okay, so at that point, if you wanted to, and you were working on a database enhancement that you needed to do, and there's a table that you have to add some columns to, and we know that nobody ever writes code that's saying do a select all, of course. Okay, we never do that. So we want to know which programs are going to be affected. After you've run a Doxygen and you've collected all the information, you can then go to that table, that database, that table, and say, tell me who's accessing this with a select statement or an update or whatever, and you've got it all, okay? For example,
So this is the Doxygen output. This is all
Yeah.
HTML.
that is correct. So,
HTML.
so here are the database tables, and I've got here this database. I don't know if, can you read this? It's, so this is all TRDB, and then these are all the different tables inside there. And then you go down, and then you, at some point, all of the procedures are going to show up. But we'll worry about that because I got about 1,000 tables in there, so I'm sorry. So we have that there. But what we also do is we do the SQL mods. Now, an SQL mod, who uses SQL mods here? Or is it mainly embedded SQL? Or for RDB? Nobody uses RDB?
Yeah.
Oh, okay, that's interesting. So if I look at a COBOL program, let's see, I'll pull up this one here. And then this is what I see. These are the functions that are built into it. And as I go down, I can look at these things that come up. So for this function here, whatever that is, okay, it's accessing the yellow database, which is the main DB. And these are the various tables in that database that that function is accessing and either updating. There's a couple of updates, insert, a delete, and 2 inserts over here. Different tables, but different functions that are going on. Okay. There's another one here. Now, this is the main program. And as you can see, it's quite extensive. Now, I've got some handouts here if you want to look at some of them.
Yeah.
Gives you an idea of what the things look like. So this is what John was talking about earlier about the call graphs, where you're able to see who calls which procedures and which procedures is called from where. And then you go after the information inside of the database if that's of interest to you. We can also do, if you don't do RDB or Oracle, we also do RMS. If you have files that you want to find out who's accessing them and where, we do the same thing. I don't have an example of that here. I've just got the one for the RDB.
Do some pointing and clicking.
I'm sorry?
Do some pointing and clicking.
Some
That's all
pointing
the
and
fun.
clicking. Okay. So if I click on here, it's going to take me to that procedure and it tells you who it's calling from and what it's doing. Okay, and this one is a local DB and it's an insert function into this table. So you can go back and forth around it. Now, another one that I have here is the schemas. And let's see, this was something that I just brought in at the end.
Not sure if that's going to be data structures. That's what John was talking about. And I'm trying to see here the various procedures that are being called. Now, we have to, COBOL, as John said, is not understood completely at all, actually, by Doxygen. So we do some replacement things, and we're building in the information where you're actually going to be getting more information from the COBOL into the procedure inside of Doxygen. So you'll have full documentation built in, but we're not there yet.
It's right now, it's just mainly call graphs, calling in, calling out,
Yeah.
and the databases.
Okay. The problem with this is that I don't recognize any of the names because it's all obfuscated. Okay. But the main DB was the big one. Okay, here, this is, it tells you how the data fields in the table that we were talking about earlier, they're right here. Everything is there. And then it tells you where everything is. So we're trying to accumulate all the information about the environment directly into Doxygen so that you know about your databases, you'll know about your files, and everything will be there together, and you'll be able to access it and look at it.
Now we've kind of forced into Doxygen some of it doesn't know about codable data types. It certainly doesn't know about timestamps. So we've kind of forced it in. For Fortran, it's more tightly integrated. So Fortran, it will actually, you can click on the actual data type. Of course, Fortran data types are much the same as C data type. So it's not like you have to deal with pat decimal and timestamps and all manner of things. But at least it gives you a good idea what's in the schema.
It's a little slow here. There we go. So if I look here and like this procedure here, okay, it gives you the information about that procedure. And what I'm trying to do is get a list, a place where you can actually point to it. Now here's a select. And then you say who uses all of this. No, that's not it. Hang on.
And you see it also brings in the source code into the document, so you can see the actual code that's doing the calling.
So in this case here, let's see, for a main DB, you want to know everybody that deletes a record or that accesses this one here. Okay. And then here's all the procedures or all the programs, all the modules that access this database table to do a select. You have a list of them right there, and you can extract that and take that with you. And then if you're doing the modification to the table that we're talking about, adding another column or something, you can go in there and you've got your exact list of the programs that access it. And you can take care of it at that point. And here's another one where we have different databases. It's accessing the local DB and the trade DB. And then you can see how many programs are accessing it, which tables are being accessed by which programs, and so on.
And you may notice, of course, that it will pick out calls to sys.ast, and then all the VMS system services will it'll pick them out as well.
Oh yes, that's a good one. So this is everything to do with the COBOL. If we are looking here at the functions, like a sys dollar. SQL CTX, sys allocate, SQL routines, and it tells you sys, like this guy here, everybody that uses sys, Actime and Tim and stuff like that, it's all there. It's really a cross-reference to give you everything that's who's calling what and where is it being called from. Okay, so it's difficult to read because I had to really scramble on names. But this is a real application at a customer site. It's one small portion. It's about 500,000 lines of code. It takes 2 minutes, 1 minute, 47 seconds to just put everything together,
Roughly
scan
1
it, put
minute,
it.
47 seconds.
Yeah,
Oddly specific.
exactly. And that's all it really is. That does take that. It takes 7 seconds to scan everything ahead of time, and 1 minute 47 for Doxygen to run through and generate all the code. And then after that, there's the post-processing that John was mentioning, where we put the colors and the shapes, and that takes about another minute and a half. So within 5 minutes, you've got the full documentation on everything that's to
Not that
do
we
with that.
timed it.
I'm sorry?
Not that we timed it or anything.
Oh, yeah, we did. Because I've been watching it a lot, going through. And then when you see that it takes a lot longer, something's going on, or if it's taking very few seconds, and you say, oh, I must have missed something. But it's always about the same time. It's really quite predictable.
Yeah, Doxygen's a beautiful tool. And if you've got VMS, C and C++ right out the bat, you can just use it, of course. Is anyone familiar with Doxygen?
Yes, it comes with the LLVM. I use it all the time. It's how they generate their documentation. So I have it in VMS. I built LLVM and I.
Oh, you did?
Yeah, I have it.
Can we borrow that? That'll make your life out like a little easier.
I mean, it generates its own documentation. Every time
Yeah.
LLVM built it scans its own source code and builds its own documentation.
Yeah, so the problem with it is though that if you've got C and C++, it's great.
It's great.
You've got Cobol, Fortran, it's very iffy. It won't handle VMS Fortran.
Do any call grind style documentation.
I'm sorry.
Call grind is a.
Oh, yeah, I know call grinder, yeah.
Yeah,
Valgrind.
yeah, it's kind of, it's a bolt-on to Valgrind, so you run your Valgrind, it gives you hotspot analysis, call stacks. So you can trace your way down through each function that you're going down, click down through it,
Right.
and it gives you a count of how many times that function is called.
Right.
And the parent routines and the child routines.
Yeah.
It's an amazing optimization tool.
It is. It is. This is a little, we use it a little differently. This becomes more of a permanent documentation than a call grind or Valgrind type.
Well, it's, yeah, there's definitely, that's a runtime profiler.
Right. Yeah,
Okay.
finding it runs all the way through without dying.
Now, for example, this is an SQL mod, and that's one of the procedures, and in that SQL mod, it's accessing this table. So if you were using SQL mods, you'd be able to figure out which programs would use which SQL mods and which SQL mods touch this database or that table. And then at that point, you get a link back all the way through to find out exactly who's doing what to whom in this case as well.
We've been quite surprised to find out there's nothing for Cobol out there. But really quite shocked. I mean, this is something that we do internally, of course, for our own code, obviously. But then clients were saying, we deliver some of this to our clients, and they were saying, can you do Cobol? And surely there's got to be something out there with all the millions of lines of Cobol out there. But no, there's nothing.
But nobody here uses COBOL, right?
We have Cobol, we use Cobol in our office. It's the guy that sits next to me that does Cobol.
Oh, yeah.
Yeah.
Let's do Cobol.
That's interesting, because we talk to a lot of customers, as you would expect, and we encounter usually a COBOL or Fortran. Those are the two big ones that we're hitting all the time. And with RDB, some Oracle, but mostly RDB and RMS. So all of a sudden, we've got now customers using this because it's working out for them. It's especially good when the application's been around for a long, long time. And whatever documentation existed eons ago has nothing to do with reality anymore. And there's no way on God's green earth you're going to go through and do that. But if you push this through this stuff, your application into there, all of a sudden, it is now documented completely. And if you need to do something to a table or extend something or modify a table or a file or something like that, you now know where to go and touch it. We've had customers look at this and say, holy crap, I didn't think this module was used anymore. And it's there, okay? Also, it's like, oh, we don't have the source code for that one. That's why it's not showing up properly. So that's another thing. If the source code is not there, it's not going to show up here, okay? But the call will be there, calling something, but we don't have the source for it. So there's going to be a broken link. And so it points this out to you. And if you're bringing new people on to support the application or whatnot, this is a great place or great way to find out how everything hangs together.
Kind of useful, I guess, when you're doing the x86 ports for your clients.
Yeah.
Assuming that they've got all the code.
That's always the fun part, is figuring that out. But this will, you give it all your code, it'll go through it, and then it's going to tell you, it will find for you the things that don't connect. That, I'm missing this, or this is not defined or whatnot. It's all there, and it's amazing how quickly you're going to clean up your code after that to make sure that it all goes through. But once you have it and it's doing it, then all these graphs are available. You can also generate PDFs out of this if you need to, printed it or something like that. They all come. Or you can get lists, JSON lists and stuff like that to say, I want to know all the modules that are used by this one, okay, or the other way around. Okay? Any questions? Any other questions?
Is it possible to create graphs from macro?
Yeah.
Absolutely. It's
Yeah,
just another
absolutely.
language.
We can detect a call in macro,
Yeah.
certainly. And it's just, so the way, we could certainly go through the macro. We could certainly detect it doing a call and throw that into Doxygen. So the answer is yes. Now, today, no, but equally, it's not like we're creating any rocket science here when we're doing this. Okay, and it's pretty obvious what we're doing. So we could certainly write a parser for macro 32, detect the calls, throw them into. That's a great use for it. Yeah, not that we see a lot of macro anymore, but the answer, I guess you got a lot of macro. And yes,
I can help you. But it's just another language. We know how to parse these things. We know what to look for. We know how to mark it up for Doxygen, and we can run it through. Just the same way as we do for SQL mods. Doxygen doesn't know anything about SQL mods. Doesn't know anything about embedded SQL, but we decipher what's in the begin exec SQL, and begin exec SQL, and end exec, everything that's in there. Select from, do, and the joins and all the other stuff, that we resolve all that, and we take care of all that and produce a list of the tables that are being accessed within that block.
And I'll say this is kind of version 1 of the product. We were just a little shocked at how many of our clients really wanted this. Version 2, which is actually involved in adding more into actual Doxygen. So creating decimal data types as a Doxygen type. Right now, of course, it's just using machine types. And by now, because in our case, we run this on a Linux partition, we will translate and include from CDD into a copybook. We extract the CDD, put it out there, change the include from CDD dictionary into a copybook. And the same with include from logical. We're going to at least translate the logical and have the include file, at least so it can pick up the include file sitting on Linux. So there is a little hokey in that way, but the front end processors handle the CDD and handle the logicals.
Okay. Any other questions?
It's also interesting, the amount of Fortran we get with embedded SQL is shocking how much there is out there.
Yes, absolutely.
We have an application with Pascal code.
Pascal, okay.
And then we use RMS files.
Okay.
Like a kind of register of database, but we have an access layer in between. So So it's like more or less like a database calls, you can
Okay.
say.
But it's a bunch of procedures, right?
Yeah,
Okay,
yeah.
yeah, so we would, and they're written in C maybe, or Pascal instead?
No, that's in Pascal.
In Pascal, and then that's fine, we'll read them as well.
So it's more or less just a need to identify the calls, so to say.
Understood.
In the access lane.
Yeah, there's absolutely no problems with that. We would put together a Pascal, well, we've got one already, a Pascal preprocessor for this, so we could beef it up and adapt for RMS and identify the file. Now, at that point, what would be interesting is that you could get a list of all the files that are being used in your application. And then we could build in like the same type of triggers that I do for tables. We could do that for files. So at that point, your code in your application, you'll know who's writing to the file, who's deleting from the file, who's updating. So yeah, we could do that. Yeah, absolutely.
I was interested with Pascal, we can actually get all cleverer. I happen to love VMS Pascal.
Don't get us started on that.
My favorite, we have a Pascal to C++ translator. So we could actually take your Pascal, move it in C++, which puts it natively into Doxygen mode.
Oh.
And the Pascal,
Yep.
the C++ looks just like Pascal. I mean, but then you'll get full Doxygen, full analysis of everything you've got, including clicking on data types. Pascal.
Okay,
I have to.
that would be fun because then you can actually sort of verify that you got the Pascal and Pascal parsing correct.
Oh, yes,
In that way.
Oh, we have it.
Sure.
Yeah, no, it's beautiful.
Yeah.
Yeah, it'd be fun though, because it's very easy for us to take Pascal, throw it to C++, and put the C, and then you've got the native Doxygen.
Yeah.
And you've got a lot of power when it's native. So right now we're creating I'm writing the parsers. Fortran is there. So Fortran is considered native. It handles VMS Fortran. COBOL is going to be a couple of months out. A native Doxygen, Lexiac, grammar, and COBOL's just a pain in the butt when it comes to
That's
grammar.
a lovely language.
Language. And so basic, we have a basic C translators, that becomes pretty easy, so we can handle that. So yeah, that'd be a lot of fun to do, to put Pascal through this. I love VMS Pascal, my favorite language.
So you guys don't develop applications or support them, your system guys, or?
Sort of maintaining and adding new functions when necessary.
Okay.
But it's for us, it's kind of a core and the new application parts and user interfaces are made in.
I understood. I get it. Okay.
Yeah, we can certainly make it do. I mean, it's only code, right? We can make this thing do whatever we really need it to do. It's just code.
Yeah, that's what it is. Ultimately, it's just code, and you just gotta know the tweaks that you needed to tell Doxygen to do this, that, and the other thing, and you get it. But it's a pain.
We found it surprisingly useful. Even I've been shocked at how useful it is. I mean, sure, I've seen millions of lines of C and C++, but actually having 6 to 7, our average 6 to 7 million lines of COBOL.
Usually
And at that point,
applications are at about that.
managing something that big,
Yeah.
it's hard work. Even do they even have all the source code? Well, is it even, it'd be even nicer if it actually templated it and figured out whether the source code you have is actually the same as the source code you started in the executable, but one thing at a time. And certainly the database access through the godsend, especially when we're moving to MariaDB, Oracle, or Postgres. Sometimes you just have to go back in and see where, if there's an issue, where it is, and certainly who's calling whom.
Yes.
You're asking a question now.
Yes, absolutely.
No, do you use oxygen filters to convert COBOL to shred-like?
I'm sorry, you wanted to use Doxygen?
There's the filter part.
Oh, the filter part? No. If you wanted to migrate COBOL, okay, there's a lovely COBOL that runs on Linux
or on another platform, if that's something that's important to you. And it's cheap. It's Fujitsu Cobalt. That one works beautifully. There's also the much more expensive, was it
Well, it used to be microphone.
Micro Focus Cobalt?
Something now,
They charge you arm, leg, and 2 feet. Okay, but but the Fujitsu is very inexpensive. There is something also known as Open Cobalt. Okay, but what that does is it converts your COBOL into C, and you can't read it. It's a mashup, okay? And it's horrible. I've seen examples of it and I ran away. And that's why all my hair is white now, because I played with it once. That's about the best you can do. We've seen some people that do conversions from COBOL to Java. That's even worse, okay? COBOL on Linux, they do have several that are ANSI COBOL, and they run beautifully. Now we have programs that will convert your OpenVMS COBOL to ANSI COBOL, and you can actually even run that if you want it on VMS. But VMS has its lovely extensions to do a lot of fun things in COBOL. One of the things that kills it is by descriptor. There's no other operating system on the planet that passes information or parameters by descriptors. And that's one of the big differences between an ANSI COBOL and a VMS COBOL is the descriptors part.
So the question was, can this be used to filter the?
No, he wanted to know if we could use the filter to transfer the COBOL, is COBOL to C or something like that. That's what you were looking at.
Was
And
that question?
yeah,
Yes.
and that's I was explaining that's not possible
COBOL to C?
over to C.
Been doing this for 40 years, that'd be horrible.
Yeah, like I said, the only one that I know of is Open COBOL. I think you've heard about it, Rob. But I've played with it several times, and it's frightening.
I mean, there's several COBOL to Java translators.
Yeah.
But the trouble is they all fall down in the VMS extensions.
Yeah.
As soon as they get by descriptor or a system service call, they're going to get only clue from CDD or any one of the 600 differences, and that's for a compiler. A lot of these COBOL translators to Java are really designed for mainframe. And so once you go even the ANSI standard is a little too strict for them. I mean, they're really designed so that you run an IBM mainframe, you're being charged by what they call it, the MIP, whatever they're using these days. The idea being that the IBM mainframes have a coprocessor, a Linux coprocessor. And if you could get things to run on a Linux coprocessor, you weren't charged by IBM for the MIP or the CPU. So that's where a lot of the translators came from with the going to Java, was to get you onto the coprocessor and eliminate some of the bidding. But when it comes to millions of lines of COBOL, towards the time.
And what John said, Open COBOL won't even look at Open VMS COBOL.
Yeah.
Because of all the extensions, it won't know what to do with it.
But this will show you if you need to know COBOL.
Okay, any other questions? All right, thank you very much.
Yeah, thank you.